Good afternoon. My name is Hugo Gaggioni. I'm going to say a few words regarding a technology that we introduced last year in prototype form, and we are bringing in commercial application for IP live transmission. I have in my hands a device that is currently available. It's the NXL IP55, and this device, in a pair of them, allows us to multiplex up to 4 HD signals in a configuration of modes. For example, three streams going one way and one stream in the return channel, or 2 and 2, over a single Cat6 gigabit Ethernet. We do this by a special IP packaging technology. This is UDP with a special precision time protocol synchronization that allows us to perfectly synchronize the video signals as if we were sending them over a standard AV router, but we are actually communicating the information using IP transmission. In addition to the audio, to the video information, we also are able to send up to 8 channels of audio, plus tally and remote and control information, intercom, in a point-to-point connection, either on gigabit Ethernet or, as I said earlier, Cat6. And as you can see here, the inputs to this box are BNC connectors to support HD SDI, and the output are just RJ45s to receive the information or to transmit the IP packaging. This is our first generation of IP communication, and as I said, uses a protocol for synchronization called Precision Time Protocol, which is based on a IEEE standard, the 1588, and Sony modified that standard to achieve this performance. It's ultra low latency, it's less than a feel of communication. Therefore, any control information that you may send from one location to from the master location to the slave location is instantly communicated to the remote cameras. This eliminates a lot of the wiring that usually takes place when we have a simple installation, like controlling BRC cameras or PTZ cameras for small switchers. We have a lot of plans for this technology, and while it's doing well in this first generation, we are preparing ourselves to move ahead to support remote productions and also the transition to 4K. And here you see our prototype of a second generation transport mechanism. This small board or daughter card will be embedded very shortly in basically all of our products: monitors, switchers, cameras, servers, in order to transmit a 4K signal over essentially a 10 gigabit fiber. We can also send a 4K RAW, one single channel of 4K RAW over a 10 gigabit fiber, or two 4K signal in a manner compressed over 10 gigabit fiber. This permits us to have a single cable implementation of otherwise would be a very complex infrastructure, which is 4K. As you know, 4K requires 4 3 gigabit signals, 12 gigabit per second. This allows us to bring down the complexity and start using standard IT switches, IT routers. Of course, we cannot change society or the industry overnight, and we have to transition from today BNC connectors and HDSCI cable to this IP interconnectivity. And we have a number of interface boxes that will go from BNC to optical interfaces or HDMI to optical IP. The connector that we are looking into using is called SFP for optical 10 gigabit, which is very robust. And the signal is a standard IP stream that can go through level 2, level 3 switches and over very long distances using dark fiber. And this is what we plan to implement in our use of 4K for future sports events. For more information on this technology and other advances, please go to sony.com/professional.